Good morning, everyone. My name is Dan Hawk, here presenting at the United Nations General Assembly 78 for the Science Summit on September 19th, 2023. Indigenous Space and the New Pioneers of Space. And today's title is From Indigenous Traditional Ecological Knowledge to the New Pioneers in Space. I want to take a note of the native spacesuit. The idea here is that we're planning on taking Native Americans and indigenous people around the world into space. Okay, introduction. Tribal World Indigenous Space. I will be just touching just a little bit on space policy because this is a science summit. I wanted to let you know that one of the things that I would like to address is the inclusion of indigenous people in space. The respect for indigenous people in space, whether it be in orbital space or if it be on the moon or Mars, as we go to, with the Artemis program, to live and work in space. One of the ideas here is that we have some human remains that have been taken to space and also put on the lunar surface, and as indigenous people we need to be included in those discussions to have equal access to space as indigenous people, as a right, as a United Nations right, a human right, a right of self-determination as indigenous people. And then we'll be talking about space technology, that we are capable, we have technology, and we have the ability to explore. So on the left-hand side of this screen, you'll see that we have Earth, and we call that as our lifeboat, right? So we're all on planet Earth. We all have to live together. We breathe the same air. We swim in the same ocean. And on the right-hand side, you see an indigenous woman in the Amazon. And she's carrying some food upon her head. And so we have to take in consideration that we have all levels of technology of our indigenous lifeways, from ancient ways to assimilated ways. One of the things that we're talking about would be Earth observation. So in other words, to take indigenous people into space, we look at a constellation of indigenous satellites around the world for supporting indigenous peoples. Space debris is one of those things that would limit our ability to go into space because at certain altitudes, as we continue to have an increased launch cadence, that the increasing launch cadence with more satellites that are being launched, that would diminish the amount of orbital space. Even though space is big, conjunction assessment is small, that we continue to increase, the cadence and the probability of collision continues to increase. And tribal space policy. So here is a photograph basically of how we do Earth observation. So we're looking at creating a network of spatial intelligence, tribal spatial intelligence from Earth observation that allows us to look at our ports, our entry, our borders, ideas about indigenous people's ability for trafficking, for drugs, and so the idea here is that we're looking at Earth observation from the point of view of Earth observation for monitoring our resources, for monitoring our habitats, for monitoring climate change. Tribal space technology. Here I wanted to mention one of the technologies that we're looking at doing, and this is has to do with creating a rover that we'll be placing on the lunar surface. And the reason why this is important is that because we are looking at the issue of how we operate in the lunar night. And the lunar night here is 14 days in darkness, and it's a minus 250 degrees. So what I'm saying here is that if we're going to go to the moon to live on the moon, to operate in the moon, we have to be able to do that in the lunar darkness. And this rover is going to be designed to do that. We have special technology for a new power source and new thermal management. And through this new power source, new thermal management, we're planning on taking this rover to the lunar surface. Lunar MOSA CubeSat standard. This is one of the things that I wanted to reveal today. We know, as I just talked about, the idea of increasing launch cadence and the way that we have changed space because we have a CubeSat standard. These CubeSat standards are 1U, 1 kilogram, 10 centimeters on a cube, very small, very sophisticated, use a PC-104 board. And so what's happening here is that if we understand how space has been transformed by these CubeSat standards, these very small, sophisticated satellites that doesn't take much to launch, doesn't take much to design and to operate. And we see the 6U CubeSats going out to Mars, around the moon. And so this Lunar MOSA CubeSat standard, which is MOSA would be the Modular Open Systems Architecture CubeSat standard for the lunar surface. What that requires is power, communications, and an attachment device. Okay, so I've been talking with Lockheed Martin and Honeybee Robotics. Honeybee Robotics has an 11-pin dust-tolerant connector, and Lockheed Martin has connection, physical and mechanical connection that can take a CubeSat and attach it to a lunar rover. We can attach it to an VSAT solar array system. We can attach it to the inside of a habitat, outside of a habitat. Like I said, we can attach it to a rover. So what does this mean? What is this about? If we understand how the CubeSats have changed orbital space, we will see that same technology be placed on the lunar surface, where this CubeSat standard can then do lunar surface science. And this is important because academics, universities, small companies, they do not have the ability to do lunar surface science like the larger corporations, the larger space industry does. So by having a Lunar MOSA CubeSat standard, that anyone that has been working on CubeSats, universities, small companies, can now transform those ideas of orbital space into lunar surface science. Okay, so and the reason why I'm working on this is because we have 32 tribal colleges and universities, and they don't particularly have the ability to do lunar surface science, and so when you look at some of the underrepresented peoples, for them to do lunar surface science, they have to have a way of doing that. And so this is the reason for the lunar surface CubeSat standard. And if you noticed in the rover, right, it was a CubeSat rover. So the first thing people will say is, well, you're going to put a rover on the moon, and its mission is to do what? Its mission is to go to the terminator where the sun and darkness meet, to be able to take measurements on when the sun hits the darkness of the moon for its highly charged electrical properties, and you're operating in the darkness at a minus 250 degrees. How do you do that on a little CubeSat rover? How can you possibly do that? Well, the reason why we can do that is because we have a nuclear power source to be able to do that. And we all know that if we have to go and operate in a permanently shadowed region of the moon, we're going to need, typically what is used is the radiothermal electric generators, the RTGs. However, there are nuclear materials that can do an equal job to that as an RTG, and it's less expense, and so that's what we're attempting to do. So here's one of my first experiments that I did in 2020 using that same technology that I was telling you about with the nuclear material. So back again to what the rover would look like if you can imagine 3U sitting on top of 6 wheels. That is what we're attempting to do. So when we talk about this rover as an example, we have now set some missions to the International Space Station. So we have 2 missions to the International Space Station that we are setting up for March and June. And from there, we also have a deep space mission that we can do, and we're also set to do the lunar rover on the surface. So this means that we're about to go into exploration, something that we have not done before. As Native American people, First Nations people, we have not done that before. So this is a first opportunity for us to do what we need to do to support the Artemis program, but also not just the Artemis program, but to show that Indigenous people have the ability to do things like we have technology, we have capability, and for the most part, Indigenous people are not thought of. They're the idea here is we should have a NASA space office of tribal affairs, and we don't. And so we have to look at how we are going to be able to support Artemis in the long run, right? So if we look at the unified vision of space, the unified vision of space says that we go into space as one people, as one vision. But when Indigenous people are left out, when we're not included, then we don't have the unified vision of space that's necessary to be able to support Artemis in the long run, right? So here we look at the idea of how we go about Indigenous people supporting Artemis, but also at the same time being able to show that Indigenous people, Indigenous companies, tribal governments have the ability to have and to design, operate their own satellites, their own constellation of satellites, to be able to monitor the resources from space, to be able to support their habitats and climate change. So back again to space debris. So I have been talking somewhat and doing some conferences about space debris, space traffic management, active debris removal, OSAM, on-service assembly manufacturing, space sustainability rating. And the United Nations says that tribal people have a right of self-determination to go into space. It's a human right. So we know, for us to design satellites, to put satellites up, to have a constellation of satellites, it's going to take a decade, right? So at the end of a decade, we're going to have another, 10,000 satellites in orbit. So the point that I'm getting at here is that the United Nations says is the right of self-determination of indigenous people to go into space. And so that's on one hand. The other hand is, oh, by the way, you're going into space at a time that you have increasing space debris, you have increasing launch cadence. And so when we talk about equal access.
Hey, good morning. Good, you?
So we talk about equal access to space. I think that equal access to space is now limited, right? So when we have these certain altitudes that are becoming more and more congested, at the time that indigenous people finally do go into space, Native Americans, First Nations people, when we finally get there, what is that crowded space going to look like? What will our access be? Will it be equal? Will we have a diminished sovereignty at that point? So we're talking about tribal space sovereignty, and then our ability to go into space, just like everybody else, but at a time of increasing debris, limits our ability to be sovereign. I noticed that my slides are they're not operating correctly, so I guess I'm going to, we'll go back to talk about the Lunar Nighthawk rover for a bit. So the two important things that I wanted to get out today was the Lunar CubeSat standards so that everybody can do lunar surface science. And again, I was going to tell you that, we're talking with Lockheed Martin to be able to have, an attachment point for these CubeSats is really important. And then also plugging the 11-pin plug-in that I was talking to you about with Honeybee Robotics. So what that does is that it provides an attachment point for your CubeSat onto anything on the lunar surface. The plug would then provide power and communication systems for that CubeSat on the lunar surface to support Artemis and the things that they have for knowledge gaps. But you can notice then, on this particular rover here that we have a 3U. It's a 3U form factor. So what is necessary again to go into the shadow region of the moon, right? So the shadow region of the moon is minus 250 degrees. Again, getting back to that. Just recently an article came out where they are determining that the earlier moon, when it formed, that there was a certain amount of water that was deposited into the permanently shadowed regions, the larger craters where the sun doesn't go, where the sun doesn't shine, where it's cold all the time, minus 400 degrees Fahrenheit as an example. These permanently shadowed regions now because there was a recent paper that came out and said that in the earlier times of the moon 4 billion years ago was different than how these craters formed in the later portion of the moon, like 1 billion years ago. And so that the way that we've determined, we've decided that we've have been able to do surface or the lunar, the L-cross as an example was able to determine that we have a water ice is going to change or may change because of how we view the earlier moon compared to the later moon, right? So when we talk about why we're going to go to the moon, right, one of the reasons that is discussed is the ability to get water ice, to be able to use the water ice for certain things, for drinking, for habitats, but also for fuel, right? So we have hydrogen and oxygen that can be separated from the water ice, and then we can create rocket fuel, and then being able to refuel, and being able to use it as the moon is a stepping stone as an example, and then going to Mars, being able to operate in the lunar surface using fuel if we can refuel. So it's important to understand the water ice. But what's missing in the equation here is that we talk about the water ice, but we don't talk about how we get it, how we go there, right? What is necessary? So this is the article saying, well, we need more data points. We need more data points in the shadowed region. We need more data points in the permanently shadowed regions. So, the idea here is we don't understand what that takes to get to the permanently shadowed region of the moon. We don't understand what it takes to operate in the lunar night. It's very difficult. Now, Namrata will be talking later today. And India was able to land their Chandrayaan landers softly and being able to deploy the rover. But then, after a short period of time, with all that great feat, right, all that importance of doing that, we put the rover and we put the lander in sleep mode. And the reason why we do that is because electronic equipment cannot survive the extreme cold weather. And that takes nuclear power to do that. It takes nuclear heaters, it takes nuclear energy to be able to allow that to happen. And I read an article with India, right? So they said, we do not have the technology. We do not, the country of India says, we do not have the technology yet to be able to survive the lunar night. And so what I have here is a rover that we're going to attempt to do just that. Not just survive the lunar night, but operate in it. And so what I'm saying is that India does have the technology to do this. If I have the technology to do this, India does. And so, how I present that, how I say that, is that what I'm suggesting here is that interested in water ice, we have to have the technology to go and get it. We have to have the technology to do the data points. We have to have the technology to operate in extreme cold weather. And the only way to do that is through nuclear power. So I'll continue on. And back again, like I said, for some reason the slides didn't transfer the way they should. This experiment here that I did in 2020 was using nuclear material. And what I did was I took this aluminum gum container and I was able to put the nuclear material inside of it. And then I was, with a single conductor, I was able to get power, right? And from that, this was in 2020. So you're saying, well, wait a minute now. If this was in 2020, we're now in 2023. What's changed? Why have things changed? And I'll tell you, this is the reason why, and I hope India is listening, that I did a lot of research into what they call triboelectric nanogenerators, piezoelectric nanogenerators, and magnetic nanogenerators. So you take the idea of nanogeneration, and you put it into nuclear material, and you look at what you can do with small amounts of nuclear power, small amounts of nuclear material, and turn it into a lot of power, right? And that's what this is about. It's about taking technology that we are understanding, and the reason why I'm saying that is because I did have a slide, and it was it's called ITEK, scientific method, and what that is all about is about interconnectedness, about being able to understand how things are connected to all other things, and by using that thinking, that Native American thinking of how things are connected to all other things, I was able to go back and look at the nanogeneration of these other different types of modes of generators, power sources, triboelectric nanogeneration, because I've been studying lunar dust. And studying the lunar dust, you're able to determine that you have two things that slide next to each other, and it creates friction and it creates power. Very similar to what we're talking about here. And I'm hoping that, after today's talk, that people will reach out to me, and I can see what are the possibilities of being able to support others in going into the shadow regions of the moon. I guess I'm back to Lunar CubeSat standard. One of the things I wanted to mention here, so I'm back to the slide, is that there's a difference here there's two different things that I'll throw out. The first one is where you take a CubeSat and you mount it to, let's say, a rover as an example, and then you plug it in and it has communications and it has power. And it's another thing to take a CubeSat like our rover, which is autonomous, take a CubeSat that's standalone, all by itself, just plop it on the lunar surface and have it being able to operate, right? So understanding those two things. One is where you have the ability to have a large rover, a large power communication system, being able to support that CubeSat. And the other thing is taking the same standard, being able to plop it on the lunar surface and walk away from it and have it operate on its own autonomously. And in order to do that, you have to have nuclear power to do that. So that is one of the implications that I'm talking about. So even though it wasn't meant to be that way, that is what will end up happening, is that for the most part, most universities, small companies will create a CubeSat to do lunar surface science. They'll turn it over to a provider, Lockheed Martin as an example, Boeing, SpaceX. They'll put it on a piece of equipment and they'll plug it in and it'll have power and communication so it'll be able to survive. The alternative to that is to take that CubeSat, plop it somewhere on the lunar surface to be able to do its science that it needs to do and walk away from it and have it continue to operate, regardless of whether it's in the sun or if it's in the darkness. Even though my slides are not the way they are supposed to be, I have a few minutes, and if there's anybody here who has a question. Is there anybody here who has a question? I know what I just said is probably pretty intense. I mean, it's regarding the CubeSats. And Robin.
I was wondering if you could speak a little bit about your due regard software.
Okay, so due regard, and perhaps Michelle will talk about that later too. But due regard, in a case of Mauritius versus UK in 2015, a tribunal said that what is due regard? What is that equal to? What does that mean? Due regard is equal to inherent rights, the extent of impairment, the value of the activity, and then alternative approaches. So they took these four elements, they put them together, and they put a little equal sign that says this is what due regard is equal to. And if you create these elements of due regard, and for some reason you breach one of those or you break one of those elements, then you've breached due regard. That's basically what they're talking about. But if you look at it and you take inherent rights, iSpace has the inherent right of landing a lander on the moon. We have inherent rights to do that. The moon also has inherent rights. But if you look at the inherent rights in general, you cannot separate inherent rights from iSpace from that of the moon. They both have equal rights. And so if you look at how the equation is set up by the tribunal, and you look at alternative approaches, if you take an alternative approach and you go to the point to where you create an alternative and you use that alternative, the alternative approach is no longer valid anymore. So really what due regard is equal to is the extent of impairment by the first state, the one that's doing the impairment, and the value of the activity of the first state, the one that is doing the impairment of the second state. So and here's a good example. When on April 20th, when SpaceX launched their large Starship rocket, and it basically blew up their launch pad, and you had debris flying 6 miles in all different directions. You know, the calculation of due regard is that they didn't breach it. And I'm wondering, like, well, how is that possible? How is it possible that when a SpaceX launched this large rocket and it had debris everywhere, it caused a fire, it was basically disastrous but did not breach due regard? Well, it's because of the fact that the value of the activity of the SpaceX Starship was so large, that the value of the activity was large, and then you have the extent of impairment, which is also large. They basically offset, and they basically no longer a breach of due regard. And so due regard in that respect does not prevent the first state from going someplace and doing impairment. It doesn't stop the first state from going to the moon and operating on the moon. It just says that you do it in a way that you take in consideration the second state. You take in consideration the moon. You take in consideration of the lander that's next to you. You take in consideration cultural heritage. You take in consideration of all those other things that you are going to impair. That is what due regard is about. It's not about stopping someone from doing something, because otherwise that could have been easily been done with SpaceX, saying, oh, you breached due regard because you blew up your launch pad and you have debris 6 miles in all different directions. That's not what due regard is about. But what has to happen is Indigenous people must use due regard, because what it does is it triggers, when the breach of due regard is triggered, what that does is it triggers consultation between the first state and the second state. So the consultation is what's important, is to be able to talk to each other, to say, look, you're about to harm me. How can we do this differently so you don't harm me? And that's what due regard is about, and it's objective due regard. So, thank you. Sorry for the slides that weren't operating properly.